I look for KSP for magnesium hydroxide. And it says 1.8 times 10 to the minus 11. As I said, you're supposed to minus 1 else in the next digit or so. So you're sure to give me more significant figures. And you're going to do the same old thing, and you're going to say I'm on to what he's doing. So this is 0, 10 to the minus 7, C. I'm going to write this over here a little bit so I don't have space. Approximation before. I'm going to do the approximation again. And so you ignore 2x, because you say this must be much smaller. And now you get x is equal to and I didn't bother putting the other number in. 1,000, 1,800. You can't get anything that concentrated. All right, I made a mistake again. I did it wrong twice now. So as soon as you do that, you say, maybe I made the approximation wrong. Maybe I should ignore 10 to the minus 7. What? What? So let's ignore 10 to the minus 7. So let's start all over again. Notice that's one of the things you can do. You can see, does my answer make sense? And you're talking about something that's insoluble. It's got a KSP. And all of a sudden you put it in there, and you got a molarity of 1,000 or bigger. In other words, I didn't want to, I guess I could have put the whole answer there. 1.8 times 10, 30. But that's enough to say, just like this over here made me think something's wrong. As soon as I saw this, so I said something's wrong. And the first thing I always examine is my mathematical solution, or my assumption. And my assumption here, maybe I should have ignored this. So I now have the problem equals x times, this is approximation again because now I'm ignoring the water. Okay, and you get 4x cubed. And you solve that. And now you get x is equal to 1.65 times 10 to the minus 4. And you see that 2x, 3.0 times 10 to the minus 4, is a lot bigger than the hydroxide ion from water. Okay? So you just made the approximation wrong. So this is a much better answer because now you can say the concentration of magnesium and the concentration of hydroxide, 2x, and minus 4. And so I ignored water this time, which I've been doing in a lot of my acid-base problems, except one of them, which I started you off with at the very beginning, which I keep mentioning, okay? Mostly because it illustrates different things that are happening here chemistry-wise. And this is the sort of thing I mentioned when we talked about the decomposition of thiocyanate. You can't have a base and an acid in the same solution because they react to make a salt. Okay? So the same thing is happening here. Yes?
So I know when you do an application for eggs, you can do it because eggs is much smaller than ASP, so how come you
Okay,
can
I
do
did
it
that in this one.
How come you can do it in the water lake? I don't understand.
Because, let me go back now and see how much I get. If I would have added 1 times 10 to the minus 7, it would have made it 3.101 times 10 to the minus 4, right? Which is much smaller than, so the water gave a lot less. But actually, water gave even less than that. How much hydroxide did the water give? This is the hydroxide from the magnesium hydroxide associating. So how much did I get from the water? Less than 10 to the minus 7, somebody said. Didn't anybody say that? I didn't hear that. It does give me less than 10 to the minus 7. Because I can now do this thing. And somebody said, why? How come you can sometimes ignore water and other times you can't? Watch what I do. Now I'm going to say, I started with this thing. I started with the magnesium hydroxide. This is 0. And the minus 4. Then the water dissociates. This is minus X. This is my I column going across here. This is my C. So this is X. This is, I just shortened it up so I can get it here. Plus X. So I'm doing the same sort of thing I did before, except this